So continuing with partial fraction decomposition, case 2. We're decomposing P over Q, the rational function, a rational function P over Q, such that Q has a repeated linear factors. Remember, case 1, we had linear factors, but they were non-repeated. They were different. So let's have an example. So example, suppose I have x plus 2 over x cubed minus 2x to the second plus x. So if I factor the denominator, let's first factor an x out. So this equals x plus 2 over x to the second minus 2x plus 1. And now this can be factored to x plus 2 over x times x minus 1 times x minus 1. So notice that they're all linear, all the factors, but I have repeated factors here. So let's go to the next page and write this, our rational function x plus 2 over x times x minus 1 times x minus 1. It doesn't matter really. You can write this as x plus 2 over x times x minus 1 squared. That's more common in textbooks to write it in this form. So now you're going to have to trust me that this is going to decompose to some a over x. I'm going to say, trust me, it's not my math. I learned it from others. So please don't think that this is my math. It is not. I wish it was. Over x minus 1 plus c over x minus 1 quantity squared. So notice that I have a over the first factor, then b over the second factor, the linear, and then plus c over x minus 1 quantity squared. Okay, so we're going to just go ahead and accept this. We are not going to go after proving this. So now let's just continue and solve for A, for B, and C. How do we proceed? Like last time, we are going to just multiply both sides of this equation, by least common denominator. Let me write it up here. We know that LCD is x minus 1 quantity squared. All right, so if I multiply both sides of this equation, on the left-hand side, I only have x plus 2. On the right-hand side, I'm going to get a times x cancels out, so I have x minus 1 to the second plus b times x minus 1 plus c times x. Okay. And now let's just simplify. Left-hand side, of course, remains the same. So x plus 2 equals a times x to the second minus 2x plus 1 plus b times x to the second minus bx plus cx. Now let's continue with this, going to the next page. So I'm going to have now x plus 2 equals, multiplying a gives me ax to the second minus 2ax plus a plus bx to the second minus bx plus cx. And now how can I organize this? X plus 2 equals. I'm going to organize the x squared together. So I have a plus b times x to the second, factoring that. And then let's go to the x's. So the coefficient of x's I have, let's say plus, I have minus 2a, minus b times, oh, and I have a c, all that times x, and I have a leftover plus a. Okay, so notice that, once again, for this equal sign to hold true, the coefficient of, since I don't have x squared on the left-hand side, a plus b must equal 0. A plus b must equal 0 because I don't have x squared on the left-hand side. And then minus 2a minus b plus c must equal 1 because the coefficient of x on both sides must be the same. This equal sign demands that. And let's see, and finally a equals 2. So I have a number here. You can think of this as ax to the 0 if you want to, but it's not necessary. So a equals 2. All right, I do have 3 equations. I have 3 unknowns. Actually, 2 is known, so that makes our lives very much easier. All right. So if a equals 2, if a, or shouldn't say since, I can say since equals 2, since a equals 2, here I have a plus b equals 0. So I know a equals minus the opposite of b, or I can say b equals opposite of a. So b equals negative 2. That was easy. Okay. And I can plug in the a and b in here and find out c. So I have minus 2a. So minus 2a minus b plus c equals 1, minus 2 times 2 minus negative 2 plus c equals 1. So this is minus 4, this is a plus 2, plus c equals 1. This gives me negative 2, adding to both sides, and so c equals 3. Okay. So let's go to the, so here I have x plus 2 over x cubed minus 2x squared plus x is breaking down to, our a was 2 over x. You can write this as plus minus 2 over x minus 1 plus 3 times x minus 1, 3 times x minus 1 to the second power. And this is the same as, of course, saying 2 over x minus 2 over x minus 1 plus 3 over x minus 1 to the second power. Okay, so notice that since the denominator had linear factors, but we had repeated factors, we couldn't use that cover until the method. All right. I'll do the third case in the next video. Thanks.